Hey, we're going take 3 right now. Take 3. 3 here. Looking here, making sure all is well. I know I'm right now coming up. Just want to see if I'm good. If you can see me right now, please let me know. If you can't right now, then we need to figure something out. Hopefully I'm coming up. Looks like I'm coming up here. If you can't right now, then we need to figure something out. Hopefully I'm coming up. Looks like I'm coming up here. All right, let's see. If you can't right now, then we need to figure something out. Hopefully I'm coming up. Looks like. All right, is it smooth right now? Is it smooth? Hopefully it's smooth. Try to start over. I don't think it's as clear as it should be right now. But if you could just text me, that'd be great. It's better? All right. Perfect. Thank goodness. All right. Hey, let's continue here. I apologize. I know that's frustrating for a lot of you. I know it's frustrating for me. And I guess we'll just do the best we can with what we've got. And we'll start off with number 7. We'll continue. Oh, yeah. Cool as the other side of the pillow. Awesome. All right. Y'all are amazing. Again, this will be take 3 here. If for some reason you want to come back, classes, and we can look at that a little bit more. But I think that if you do it collaboratively among your members, more of my time too, since I already did it previously. One thing I can do though, and again, keep giving me updates if for some reason it's not working. Okay. I had a question regarding number 16, and I'm really afraid to pull the internet up. Isn't that crazy? Could you do me a favor? If you could, I'm going to clear out all the questions, and if you could, so that I don't have to keep pulling it up on my Mac, if you could take a picture of the question and then send it to me, that way I can see it. And then what we'll do is we're going to clear the database here of my phone, and any questions that you have, we can just go right straight. We'll go right straight back from the beginning because I don't have that with me. So if you could, the first one that kind of gives me a question will be the first one that I'll use. I think number 7 was one that I was going to do. Number 7 involved, if you remember, let's see. Okay, let's put this here. All right, number 7 involved one where when we approached it, what we wanted to do is find the angles of all of these values. So let's say let's say we have this. Let's say we've got, I think it was A is equal to 6, B is equal to 9, and C is equal to 10, okay? So we have A, B, and C, and within all of these 3, what we have right now is we have a triangle that's created. So we've got big angle A, big angle B, little b, and big angle C with little c, okay? Now remember that within all of these values, what we can do is plug in what we know. So we know we have a 6, we know over here we have a 9, and then over here we have, A is equal to 4, I'm sorry. Sorry about that, y'all. Yeah, keep fixing that because, again, I need some help. I don't want to open up the internet. I'm afraid what it might happen. It might spaz out on me. So now we've got 9, 4, and 10. Now, in all of these situations, you could use a law of cosine. Remember, we have one that's like A squared equals or B squared equals or C squared equals. So technically, you could use any of those because it's a side triangle. We know based on our what we've done in the past, we know it would be law of sines. Okay, law of sines. And someone just texted me too. This was 6. Okay. So again, we're just gonna be patient with each other. How about that? And C equals 9. Okay, that helps me. That helps me now. All right. C equals 9. Now, after I get a side, I know that I'm not going to, I said law of sines because I was looking at stuff. We're going to do the law of cosines when we end up having a side. Now, within that flip chart, one thing that's important is to notice that law of cosines with side, side, side states to actually do the largest side first. Do the large side first. So let's look at that one. So let's find the largest side, c squared, and let's plug in everything we know. So we know it's c squared equals a squared plus b squared minus 2ab cosine of big C. Now, if I know all this information, what I can do is put in 9 squared equals 4 squared would be a squared plus 6 squared is b squared minus 2a times b would be 24 cosine of C, right? So we did everything that we figured out there, everything we know. So 16 plus 36 minus 48 cosine of C. Now, I'll tell you what a huge problem is, and everybody does it. I don't know why we do it, but we do it all the time, is anytime we approach a problem that is like this, we immediately subtract these, when in actuality, you really can't. So what we need to do is take 52 and subtract 48 cosine of C. So right here, I actually can't take 52 minus 48 because 48 cosine of C is like 1, right? So we have to subtract 52 to the other side. Sparks fly like the 4th of July. Take it to the other side. When we end up subtracting, we get 29. So we get 29 equals negative 48 cosine of C. Well, to get C isolated, we have to divide by this negative 48 here, to where now we have 29 over negative 48 equals cosine of C. Well, in taking that C and isolating that C, we can actually take cosine inverse of both sides. So the cosine inverse of 29 over negative 48, cosine inverse 29 divided by negative 48 is 127.17 degrees. So what we have for angle C is 127.17 degrees. So that's angle C. Well, once I find what angle C is, I can solve for A and B by using the law of sines. So I could say sine of big C, which is 127.17, over little c, which is 9, equals sine of, and you can choose either or. As long as you chose the larger side first, you can choose either or. So sine of big A all over 4 will end up cross multiplying to get 4 sine of 127, 4 sine of 127.17, divide that by 9, and then take the sine inverse of that. Okay? When I do that, I get 20.74, and really we could round to the nearest degree, so we could say 127 degrees, and over here we could say 21 degrees is angle A. So 21 plus 127 subtracted from 180 gets me 148 subtracted from 180, which is 32. So 32 degrees would end up being what angle B is, where angle A is 21 degrees. All right? So I hope that was helpful for you. I know I'm going through that very quickly, but hopefully that was helpful for you moving forward off that. All right. Awesome. Also, shout out to Dynasty. She's performing tomorrow. Pray for her and wish her good luck tomorrow. I'm really excited for her for sure. All right, next one. Getting the sniffles here. Let me see here. Let me go up. Not that one. Not that one. There we go, 16. A plane is flying at an airspeed of 400 miles per hour. Perfect. Okay, let's do this thing. All right, remember, plane plus wind equals ground speed. Okay, plane plus wind equals ground speed. First of all, we figure out that 400 miles per hour. Okay, 400 miles per hour is at a degree of 204 degrees. Okay, 204 degrees. So we're going to relate that to the plane. The wind is related. It states that it's 45 miles per hour blowing from the east. So if it's from the east, right, from this right side, that means it's going to the left. So if you think about it, it's going really just to the left side. So going to the left, so you could say it's at 180 degrees if you wanted to. You don't have to, but you could say that. And it's at 45 miles per hour. Okay? Now, first step. Remember, first step is graphing. Okay? So in graphing, we want to take the first problem at 204 degrees and know that it's in quadrant 3. Okay? So 204 degrees would be in quadrant 3, where the magnitude was 400 miles per hour. Again, that is the magnitude that it travels. So we come over to the wind. Okay, come to the wind. Remember that if it's from the east, that means it's going towards the right side, right? It means goes towards the or it comes from the right, going to the left, and it's at 45 miles per hour towards the left side. Now, since this is not on, and by the way, we did graph it, right? We already got it graphed. Perfect. Since it's already on my axis, I know that there's no transformation up and down. So the only transformation is left and right, which would be I, right? So we could say negative 45I is vector, we'll put it as W, vector W. So vector W is negative 45I because there's no transformation on the J. We just simply go towards the left side. Now with this one, we have to get a triangle where we solve for both I and J. Note too, both of these being negative because I and J are go to the left and go down as well. Now, just like before, you could actually find that angle by taking 204, subtracting 180 to find 24 degrees within this spot here. So when we use sine and cosine, just like we did on the previous problem, or one that we did in vector 1, not vector 3 here, what we're going to do is follow the sine and cosine with a 24. So put 24 on the outside, and what we're going to do is put 400 on the outside of sine, and on the inside we'll put the degrees. So the degrees always go after the sine and cosine. So 400 sine of 24 and 400 cosine of 24 gets me what I and J is. Note, I is related with cosine, J related with sine. Okay, so let me look at this. Let me see this here. So 400 sine of 24 and 400 cosine of 24. The cosine one is 365.41 I, and the J or the sine is 16. I forgot to do that one. 400 sine of 24. There we go. 162.69. 162.69 J. Again, both of these are negative. Remember, note that it goes left and down. Therefore, both will be negative, and that is vector V. So when we combine these, before, remember, we were given plane and ground speed, and we had to subtract plane from ground speed and go from there. But on this one, we have to combine both the I's and the J's. Well, since there's not any J, that's perfect. We just say 45, or negative 45, minus 365.41. Okay? So we get 410.41 I minus 162.69 J. And again, this should be negative. And again, that's the resultant vector right there. Okay, so we've graphed it. We find it in terms of I and J. We found that. That's step 2. Step 3 is find the resultant. We did that already. Okay, we found the resultant. That's this right here. Step 4 now is find the magnitude. Remember, the magnitude, though, is what we find when we take the square root of a squared plus b squared, or negative 410.41 squared, plus negative 162.69 squared. Now, when I plug that in, it may take a little bit, but let's see if we got this here. 410.41, square that. And again, 162.69, square that one. Once we end up getting that, we end up finding the square root of both sides, or just the answer. And when we do, this is what I got. I got 441.48. So that right there would be my magnitude of vector u. Okay. Now, how do I find what the direction angle is? Well, in the direction angle, a direction angle is when we go to the we can graph this. We know we go left 410, right, 0.41, and we go down negative 162.69. So to find out what the theta is, okay, theta being here, I know that this distance is 180. So once I find this, I could take 180 and add that together. Well, remember, how do I find the angle? I can find tan inverse of the opposite over the adjacent. So negative 162.4 or 69, I'm sorry, over negative 410.41. Okay, so let's do a tan inverse. 162.69 Okay, so sorry, I cleared that out. 162.69 divided by 410.41. Okay, get that? So I got 21.62 degrees. So if that's 21.62, we're going to add 180 to it to get 201.62 degrees. 201.62 degrees. And that right there would be the direction angle, magnitude we found down here, direction angle would end up being that angle right there. All right. All right. That was a doozy, huh? Real doozy there. Do you have any other ones for me? Maybe you have some at home, maybe that you're looking at. And you're thinking, man, this one's a tough one. I don't really know about this one. And if so, you could kind of put that there. One that I could do, we could do it right here, and I could just make up numbers. But this is one that you just do not miss this one. Do not miss this one, all right? It's one where it gives the initial terminal. Let's say the initial point is 3, -2. Terminal is 4, 0, right? I could make it up. Again, numbers may be different. The reality is that that's what it is. Now, you don't have to graph it, but let's say we did. We know 3, -2 is down here where 4, 0 would be here. We're trying to find the vector as it goes from my initial towards my terminal, which would be right in this location here, okay? Now, how do I do that? Well, I know that my vector v is equal to ai plus bj, right? We know that. So because of that, what we've got to do is we know that the a is associated to my x. So we have x2 minus x1, which is my I. And the b would be the y2 minus y1. That would be associated with my j, right? So how do I figure that out? That's the question. Well, again, x2 always associates with the terminal. Terminal means ending, right? Where the initial would be the first. So we plug it in as x2 minus x1, or 4 minus 3. Okay, that goes in with that, with I. The next one is y2 minus y1, or 0 minus -2. And that's associated with we've got a 1i, or just I, plus 2j. And that right there, I plus 2j, magnitude of it, we could actually find the magnitude by taking the square root of 1 squared plus 2 squared. All right, remember how to graph I plus 2j, just so you know? That means we go to the right one and up 2. Okay, so it should look something like that. So if you have questions on that, hopefully that was helpful for you. And again, what I might do is say graph this, find what the magnitude is. It'd be the square root of 1 squared plus 2 squared. Okay. All right. Fantastic. Do you have any other questions out there? Any other questions? I mean, I have 6 viewers right now. I know a ton of other people are going to watch this before tomorrow. Again, I apologize for the 3rd time. My goodness, I can't believe that happened today. But hopefully, it's been smoother sailing today. So if you've got questions, text me. We'll get those up and running. One thing also to note is an angle side problem. Remember, if I have an angle side, let's say this is 80 degrees, and this is 8, and this is 7. Remember, this would be angle side or side angle. So you could write it either way. A lot of people, yeah, anyway, you could either write it one way or the other way. But the idea is angle side or side angle is where we're trying to find whether we have 0, 1, or 2 triangles. If it's an air, remember, that would be no solution. And if it was, if I found one of the angles, right? So if I was given, let's say that was B, we know that the given angle is associated to both the first and possible second triangle, right? And whatever one I found first, let's say A was the one I found first, I could, let's say I got 100, or let's say I got 70 degrees, okay? Remember, 3 places add up to be equal to 180. The first one and its counterpart, and then the 2 up and down. So if this is 150, 150 subtracted from 180 is 30. 70 subtracted from 180 is 110. 110 plus 80 is actually greater than 180. So actually there's no second triangle, only the first triangle. And that's how I would solve for using law of sines there. Also remember that when I solve for like this variable, If I have two triangles, make sure I solve for both of them. If I only have one triangle, then you only need to solve for the first one. So this one would be, if I had to solve for this one, it could be 30 degrees that I would actually look at and implement for that one. All right. Fantastic. Hopefully this is helping you right now. I kind of wait for if there's any other questions that are there. If not, we can be done. I'm trying to think of another word problem. I'm trying to think. What else is on there? Got vectors. We did that. I'm trying to think. 1, 2, 3, 4, 5. I know I'm missing one. I think that's it. Hey, remember too, the flip chart's pretty big. Remember the flip chart. Again, how do I use that? How do I apply it? How do I implement law of cosines in there? And how do I get out solutions in that way? If you really understand the word problem and you really look at that tonight, it's going to be a huge help to you off that, all right? All right, I'm going to give another 20 seconds or so. If I don't get anything back, that's no problem. But I'll be done for today, tonight, and we'll go from there. So if you have any questions, last-minute questions, let me know. But other than that, we're going to call it a night, and tomorrow we'll get after it. We'll get after it tomorrow. Remember, law of sines and cosines is first, followed by the vectors. Make sure your review sheet's done. Care about y'all. Hey, have a great night, and I will see you tomorrow. Bye now.